So, thank you all for joining us on this talk. So, as Olaf said, I tried to catch the text fata morgana. So, first of all, I would like to give you a short introduction of what I plan to talk about. So, a short introduction of who is ABBY, what we do, what our key competences are. Then dig into the problem, why this critical thing that not everything in a PDF looks like text is really text, why this can happen and what the problems are. And of course, finally, provide you a solution or different approaches how you can solve this problem when nobody else can actually solve the problem. Who is ABBY? ABBY is an international consortium with different offices all over the world. We were funded in 1989. We have around 1,200 employees worldwide. Our headquarters is still located in Moscow and was originally in Moscow. And there we have close to 400 developers and linguists working on different ABBY technologies. So what do all these guys do? In Europe or in the rest of the world, ABBY is mostly famous for its OCR technology. And this is what we develop from bottom up. We provide our technologies in different flavors. So our most famous and well-known product is ABBY FineReader on the desktop side, because it was bundled with a lot of scanners. But we also have server-based applications for data extraction, for document conversion, like FlexiCapture Recognition Server. We provide a lot of SDKs for Linux, Windows, Mac, but also on the mobile space for mobile imaging. We have a toolkit running on iOS, Android, and even Symbian if you would like to have it, because this is where we started our mobile business back in 2006. Also, we offer services in the cloud. That was a topic before as well. So ABBY runs a cloud OCR service where you can just, via REST APIs, submit us an image, we do the job, you get the result. You don't have to integrate anything, so that's easy for cloud-to-cloud solutions and others. And with our technology, we think we power 40, 50 million users all over the world. We do not really know exactly, because a lot of people do not see our core technologies. So what is my role in ABBY? So I'm located in Munich, and from Munich we are serving the Western European countries. I used to be product marketing, product manager for different product lines, and since the end of last year my role changed a little bit, and I'm now technology evangelist. I'm talking about different technologies ABBY has. One part of it is the core OCR stuff. I've worked for the last almost 10 years, and another part will be the upcoming technologies about semantic text analysis and semantic text processing. And this actually brings us to the next topic. Why I chose to speak about text and the image of Fata Morgana, or in English it's mirage. So if you go through the desert, you're thirsty, and then suddenly you see something where you want to be, you get some water, you get some shade, that's good. But in business processing of documents, you can exactly have the same. So for example, you do a report, and then you find a PDF where all the information is, and you just want to access it. And then you try to copy-paste. What you see is you cannot copy-paste anything. If you can paste or copy something out, it might be complete garbage. The text might not be in the right reading order or whatever. So what to do then? And this is what I want to cover in this talk. First of all, I would like to introduce why this actually can happen. And a very simple way is, traditionally, a lot of documents were scanned, and the result was a TIFF or a JPEG file. And it's very simple to put a TIFF into a PDF envelope, and what you actually get is a final PDF. Looks like a PDF, but you cannot access the text. You can perfectly read it, you can print it. And users at the beginning of PDF were used to these kind of things, because a lot of scanners produce PDF, so they actually learned about that. Yesterday we also talked about we should skip the whole thing and not allow that. But actually there is a big advantage, because in a PDF you can put 20 pages in one PDF, so you don't have to deal with 20 individual images and somehow get all of them, because it's easy to lose them, so it's quite a good thing. But from a text access point of view, out of the box it does not work. Of course, there's Digitalborn PDFs. Then I just made a very simple test. I thought, okay, the simplest thing, if you program something, try to make a Hello World sample. So what I did is I run it through a printer driver, made it a very simple PDF, then I changed the extension, And then I just saw the result. So from 2 words, you get a PDF with over 100 lines of code. And actually the words hello world are not encoded in plain text. So what I want to say, it's not so easy to find the stuff. You have to be an expert to get the whole thing. And on the next slides, I copied or I borrowed some slides from Luis Fernandez from Levigo Solutions. Back in 2012, he had a nice talk about how to extract text from PDF. And just in these 4 slides I have, it just shows the basic principle. So you have some binary data and you convert that in a visual representation. That's the magic of PDF and how it happens. But as you can see, there are different encodings. So you get exactly the same visual representation, but you have exact different encodings. That's not the only thing you have. You can also have certain binary information, but you render it in a completely different way based on the font type you have. And of course, you can combine that. So it's quite obvious, it's not so easy what you actually want to get and how to encode and if the encoding is there or not. Finally, there's something like that. You can have glyphs, which can be just vectors. It renders perfectly, it prints perfectly. It's not pixel information, but still you cannot access the information because it's just a vector. So, and this is not something which is illegal. This is just the way how it works. So, in the next slide, I just wanted to give you some historical thoughts to make the borders of this talk. So, PDF has its roots in PostScript and printing. And it was developed for visual representation. So the idea was to have a universal document format which renders nicely. Editing or accessing the content of that was not part of the whole project. Also, PDFs can, over the years, got the ability to include a lot of additional information, like movies, like 3D data, like JavaScript, like metadata, all these kind of things. So imagine this just simple PDF I've shown you could be dramatically longer, but it still looks the same. PDF files internally can be and are extremely unstructured. That's an important thing because it's not standardized, it's not XML based. And here I have a quote from Leonard from Adobe, and he on one of the conferences he said, well, when we designed PDFs, validation was not what we had in mind. So they tried to build a system which is flexible, which renders very well, which works good, but it was never to design to validate. Another thing we have to see, since it has a printing approach, so like a big canvas, you can print hello world and you can make the first 2 characters green, blue, whatever. So as a word user, you would say, okay, I type the characters, the words, and then I just change the color of the text. This is what everybody thinks of. But from a PDF printing point of view, it is completely okay to print 2 green characters on top of the document, and at the end you print black characters and just put it close to each other. So then it looks like that, but it's not actually a logical structure. I'm not sure who said that, but this was also one of the PDF gurus, that there are 40 different ways to print an A or to display an A. And of course, the ASCII or Unicode variants are just only one of them. So it can be pixels, it can be vectors, it can be masks. No idea what else you can use, and I said probably it's even more than 40. But it just shows that displaying text or something that should be text is not so easy. All the other things were on a word level, how you can print them. But if you go on a document level, it is also completely legal if you have a multi-column text to create the PDF line by line. So you have the text there, it might be properly encoded, but if you try to extract it low level, you don't get the reading order of the text. For a human, it is obvious that column 1, column 2, column 3, but from a programmatic point of view, nobody forces you to tag the text correct. So it might be okay that you get the text, but not in the correct reading order. For some scenarios like search and indexing, that might be okay because you care about the words, but for usability and humans, that's not what you want. On the other hand, this was historic data. PDFs in reality are a business standard and it's an ISO standard. So we talked about that. Also users love PDFs because they're flexible, they want to do everything, but users do not really know what's inside the PDFs. The same with developers. here are experts, so they know exactly what they do with PDFs, but there's a ton of developers out there who use libraries in the wrong way or do not follow, have never read the specifications. They just get a piece of text somewhere from a website, integrate it, change it a little bit, and then they get something which renders nicely in Acrobat, but internally the structure might be completely weird and not working. Also, we have the fact PDF-A is already an established long-term archiving format, which is actually good. And we also know that PDFs and optical character recognition are a very perfectly good fit. Because then you have a format where you combine the original image information from the scanned document with your text layer and the metadata and treat it as a whole document inside. So now I would dig a little bit into more, because I'm not expecting that everybody knows what OCR is. The OCR is optical character recognition. But in a few minutes, hopefully you know that it is not only character recognition. This is what people actually do not really see. So you can have images from a lot of different sources. You can scan them, you can take your mobile phone, capture a business card. You have MFPs, you have Fuchs servers, all these kind of things. So if you have images, you use them as an input source for an OCR program, for an OCR technology, an OCR engine. And the first thing the whole system has to do is pre-process the image. Pre-processing actually means, like, if you have a scanned image, it can be skewed. If you have put a book on a scanner, or like an MFP, you might cut it in half so that you have two separate pages, then you can deskew the pages. You can remove the noise from scanning, the dirt from the scanner, from the documents. Then you clean it, and then you start doing some more stuff, because then you have just pixels, and then you have to apply intelligence to analyze the layout. So you have to make a distinction between what is text, what is an image, what is a barcode, what is a table. You can do that manually, but nobody would do that because it's too time consuming, so algorithms have to do that. Once you have found your text blocks, you have to separate the characters into lines, into words, and into individual characters. And only then the actual character recognition takes place. Then, depending on the technology, you have up to 15, 20 different classifiers to read these individual characters. And sometimes it's like a voting. Everyone has a different opinion. You have to bring that together. And then from these different votings, you go back and reassemble the words. There, you might use language information, like morphology dictionaries and the character sets. You know which documents, which is allowed in the document, to get a very good result out of that. Still, then we have the words, and because of the layout analysis, we have the coordinates. And the last thing, you can verify the results, so by an operator, but this is an optional step. Might make sense in some scenarios, like when you convert contracts into Word files, and it's better to correct all the errors before you do the export, because then the OCR technology can assist you where it is not sure how it was recognized correctly. And at the end, once you have this all layout information about the document, you can do the synthesis part. And then you can make a searchable PDF, you can make an image-only PDF, you can convert into Word files, you can give all the information the OCR engine has detected in an XML file. You can have plain text, you can have EPUB or HTML formats, so all these different things, what you can do when you understood what is on that page. The next slide, I just have a small illustration from ABBY Fine Reader, how a typical desktop OCR software looks like. So on the left side, you have the pages of the document. Then on the top, or in the middle left, you have the layout detection and the result of the layout detection. On the right side, you see actually the recognition result, and where the cursor is, on the bottom part, you can actually see the highlights, what the characters look like. So this is a typical verification interface that is used in our products, and for developers it's available as visual components so that it is easy to work with and you can give your users this kind of experience. You can also see that there's formatting information like headline number 2 and font restriction, all these kind of things are tried, or we try to determine which information is available in that printed document. So this is the typical scenario about OCR. And now we come to the next point. How does that fit to PDF processing? as I tried to explain before, every PDF has to be rendered. So this programming code has to be turned into an image so that you actually see something. And in ABBY technology, we use the Adobe PDF library for rendering. So you have seen we're acting on a global space, so we have Chinese, Hebrew, Arabic, Cyrillic, all different kind of languages. So we want, or we need a library that is really able to handle all these kind of things. And while you open the PDFs, all the PDFs have to be rendered. So opening a large PDF file, which might be only 200, 300K, but generated electronically, might actually generate internally a lot of data, for temporary data, to have all this image information, all that stuff. Also, when you open the PDFs, you have to respect the PDF security settings. Are you allowed to process it, or ask the user for the password to enter the stuff? For developers, sometimes it's important to get the stuff directly from memory and not work with files. Also, you can specify the rendering resolution. That's important on the text size when you get the whole things. And you have internally the information. Once you have the image, the difference between a rendered PDF image, normally that's very clear. And via API, you can define how detailed you want to render it. So 200 dpi's, 300, 600, whatever might be needed. And then in the illustration at the bottom, you can see that you have an image, you have a table, and you have two text blocks. And you can see the image was detected with a red border, which means this is an image block. Different text blocks were detected, and also the table was detected as a table, and also the table structure was analyzed. This is important, especially when you go to Word. We want to reconstruct the table in Word, but of course this information is there because the engine, the technology knows it, so that also developers could use this kind of information. Also additionally, we have barcodes, which is not typical character recognition, but we find the barcodes, and also we provide the values to them. So now when we come to the next step, when we talk about intelligent PDF processing, there are three different main scenarios. When you know that you have to process PDFs and they're in good quality, actually do not need OCR, because there are libraries like iText or the PDF-lib or the Adobe library where you can directly try to get the textual information out of the document. So yes, in your application you can say, if there's a text layer and I know it's from a well-known source, I trust the whole thing, you don't need OCR. That's an ideal situation. Fine, you can leave now. If this is the case in your scenario, don't care about it. But much more, you have the scenario that you do not know what you get. So you have the text layer, or the text quality in the PDFs is completely uncertain. So how to process that? So the idea is actually, since we have to render the PDF anyway, and since we have all the technologies from the OCR background, we make a layout analysis. So we look ourselves just on the rendered image, so what the final image should be. We grab different text areas, we just make a short OCR on these areas, and then look into the text layer of the PDF, and then compare the two of them. If there is a match, perfect. So we don't have to do anything, or we just leave it as it is, depending on the processing settings. Or if it does not match, we actually can say, okay, trash the text layer, apply OCR, and work it out and do it on your own. The last thing is, what also happens is, you know that you have poor quality PDFs, you just can force the OCR and you said, trash the text layer anyway and apply your technology. The idea, the different use case scenarios, so the first one saves you processing time. The second one is just helps you to detect if the quality is good or not, so that you have a certain reliability on the processing. And the last one is normally used like brute force technologies, when you say, when I always use ABBY technology to get a text layer or to make tag PDFs, fine, then at least I know I have a certain level of quality I can rely on. Also, the whole process I've described generates a lot of metadata through the PDF, because sometimes it's, as I said, the PDF can be very messy inside. So with the OCR engine, you know at least that you get proper encoded text. You know where all the image areas are, you know where the tables are, you can have access to the table structure. You get all the coordinates of the text. This is important when you want to reconstruct another document format, because you get all the positions. But also additionally, our technology is able if you have a multi-page document like a contract or a book, we try to understand the document as it is. And this allows you to identify the headlines, to reconstruct maybe the table of content, that you, the footnotes are detected, you get the information, what is a caption under an image, for example, all these kind of things. So this is an information that you can actually use to enhance an existing PDF. This is what Luratech does. This is what the guys from PDF tools in Switzerland do. So they use this information combined with their own libraries. And once you have the text, you can decide, okay, sometimes the PDFs are rather complicated, and what you then can do is just say, okay, insert the new text layer, or replace the existing one, then the rest of the PDF is untouched, the top image is untouched, all these kind of things. It's just a new text layer in the PDF. Or at the end you can use all the information to create a completely new PDF. So this PDF then, at the end, should ideally look exactly as the original, but you might change the PDF version. So you can say, I want PDF A, PDF A2, I want PDF 1.7 with certain types of passwords or encryptions. You can say, I want all images in color, black and white, or compressed, uncompressed. You can specify the image resolution, because you do not really know that it's unified or not. You can create bookmarks yourself, or you can use the bookmarks automatically suggested from the document structure analysis. You can define if you want the hyperlinks to be hyperlinks or not. So this is when you create a completely new PDF. Also, when you export the whole things, there are other options you can set, or you have to set. You can say, I want an image-only PDF, I want the original image on top, and the text layer in between, or just say, completely trash the top image, just make it a text-only PDF. You can specify passwords and access restrictions. You can say linearize the PDF, so if you put it on a web server, that it is served page by page already. So if you have 100-page PDF, you already see the first page while the rest is still loading. And also what we can do is we can create tag PDFs based on our layout analysis. This actually works quite good because we know that a lot of blind people rely on our technologies, or software providers who use OCR technology to build completely new PDFs and say, okay, the images are not relevant anyway, so we just extract the text, we get it in the right reading order. And these guys know there might be slight OCR errors, but still it gives them complete access to the textual information in such documents. Summary. So there are multiple reasons why you cannot access the textual information that you see. As I said, it could be images, which is obvious. It could be text as vectors. It could be font or encoding issues, or missing font issues, or you have the glyphs but you do not know which Unicode characters is, or the complete internal structure of the PDF is something that you cannot easily parse it natively. The core technologies coming out of the OCR development that is now ongoing for over 20 years has layout analysis, it has character recognition, it reconstructs the words, it removes when words are getrennt? Hyphenated through the other line, so you can reconstruct it for full text accessibility. Then of course we have multi-language support and also mixed type of documents. This is also information you get when you use toolkits. The engine guesses and uses dictionaries to look it up, what language might be the proper one. You detect the reading order of the text. It works also very good. Imagine what I said, we have X million users, so a hell lot of documents are processed every day with OCR technology, not just from ABBY. So this works really very reliable. You can reconstruct the layout, and last but not least, you have flexible output options, of course to PDF, but also to other formats, like editing, these kind of things. And if you look at Fuchs or the Nitro PDF conversion tools, all of them have an OCR engine inside to deal with that, because otherwise there are scenarios where you cannot really work with the PDFs, and the users actually expect that they can somehow access the text, because they do not all know what's going on behind the scene. So, and in our opinion, we think that OCR technology, when you're not 100% sure what type of qualities or documents you get in, that we think, of course, OCR is a very helpful tool or set of technologies to actually build reliable workflows in your organization if you want to extract text. because otherwise we see no chance how to get information that is vectorized or in images, or we have images where text is in an image, or what we had in the usability session before, a Word document that has a diagram inside which was just scanned and put in. So to get all this information out, it is really useful to have an additional expert to look at the whole thing. And as I said, it's not just OCR, it's not just the character recognition part what makes the whole technology interesting. It's really the rendering, it's all the access and all the metadata. And this is what the top providers actually use and integrate in their solutions. So that's it, more or less from my side. So I've done it in 25 minutes. So I hope if you have some more questions, I'm free to answer that, and hope you're still alive in the wake after lunch.
I would be curious, who of you is using OCR technology for documents other than scanned documents? And for scanning it's obvious, but you were just explaining that you could use OCR on a document with uncertain origin or quality. Anyway, you're...
Yeah.
Photos.
Photos, okay.
Born digital PDF.
And you use OCR on born
Yeah,
digital
yeah.
PDFs because you never trust the encoding. Okay.
Question. When you, with your text of variable quality with a bad encoding, why don't you just OCR glyphs in font rather than the basic representation on a page?
Because the core OCR technology is normally developed on a word level, because you use all the linguistic information, and if certain glyphs appear multiple times in a document in different words, and you know that these are proper words in English, in German, in French, then it makes it just more reliable to use the whole approach. And also, it's often the case, or this is what our customers tell me, especially in the clipping industry where you have newspapers and a lot of PDFs on the internet, on purpose. You can read the documents by looking at them, but the text layer just tells you something completely different. Or the text layer doesn't really match the original layout. So it's completely squeezed on another thing. So this is why all this layout analysis is just an independent view on the document. And then the whole technology, you can decide if you want ASCII code, Unicode, Mac, encoding, all whatever you want. So we're completely supporting all these different things. Good. So it's just a thought about kind of technology which everybody has heard of, but is probably not aware that it can also be very useful in OCR scenarios and terms. Good. Thank you for your attention. Another one? Yeah.
We think OCR is something that's working quite good on some level. And can you explain some of the next goals you are trying to do, or where is the OCR moving in the next time?
Yeah.
What problems currently you have, or something like that?
I have to go a little bit back where it was moving in the past. So ABBY started a few years ago already, in old days, every page was treated as an individual page, and just OCR, and then the documents were assembled. So for ABBY, the next step was actually to understand the document as a whole. So to detect where are the page numbers, what are headlines, what are all these kind of things, what are footnotes. And our goal was just to make an intelligent Word document. And the original goal was to reconstruct a table of content. If you have that in a book, that you just click in the PDF or in the Word and it brings you to the correct page. This works after a few generations of technologies and a lot of brain investment and coding time. So our colleagues managed that quite well. It does not work on all characters. So this was one thing. And at that time it was kind of not obvious why you want to do that, but now we are getting there because the long-term goal of ABBY is really to understand the document. And all this meta information helps you to know what's inside. This was one part for the OCR. We already started a few years ago to deal with camera OCR. This is what we call, so take your mobile camera or now your mobile phone, your iPad, and grab a piece of printed information. And therefore this brings the core technology to a completely new level, because if you put a document into a scanner, you have more or less straight scanning, you have a defined scan resolution, there is no shadows, no something. But if you take a picture from a camera, you have geometrical distortions, you have shades. Normally people do this in the pub or wherever. So they do not really care about taking a sharp picture. Also, low lighting conditions. So the image quality is actually decreasing, and the challenges for OCR are going up. So we invested a hell lot of image pre-processing, like ISO noise filtering, so this camera noise, horizontal skewing, and changing the geometrical stuff. Binarization was adapted, because if you have the lamp here and you take a picture here, then you have shades of a hand or whatever. So just to equalize that before you send the image to binarization. So this brought us really in better results on low quality images in all kinds. This now works well. It works on the server, and over the time we put that on the mobile devices as well, to tell people right when they capture the information, it's thumbs up or thumbs down or better not. This is one thing. With the information we've seen, still recognition quality is an issue. Especially tables are still a challenge, because there are so many different tables and table logics that people want to reconstruct 100%. So this is what we're looking at, and also text quality reconstruction. As I said, part of my work, I'm working for the text semantic analysis stuff. And if you look at real proper text, it makes a big difference if there's a comma or if there's a dot from the logical order of the sentence. So this is something we're also looking at to improve OCR technology in the future. This is something we're actually in progress. This is work, a lot of this was already achieved. So the next steps are, we're going to types of documents which are hard to read, like, for example, receipt capture. So if you have the printed receipts in a supermarket. So they are printed all over the world. There's a lot of information of that, and a lot of companies want to use loyalty programs. They want to, for travel expense management, like fuel stuff, to automate all these kind of things. And it brings the OCR again to a new border, because it's very long documents. The document structure is different. You have different line items. So develop something which works quite good on that stuff. Also, what we're trying to do is using the video stream of mobile phones to get certain text more or less OCR on the fly to show translation. So we're expecting some toolkits in this area. So it goes in different directions. PDF processing, of course, is important. So this is also what we are following, and of course we try then to adjust new features, new standards. So there's still ongoing work, and there's not this big, huge, that's the new thing, but it's continuously making it better.
Thanks for exhausting answer.
Yeah, I had some time, so I was quick. And
Any
it's
other
actually,
questions?
it's my marketing pitch, so.
Any other questions? If not, I would like to thank you.
Welcome.